Imagine falling through space into a hole so dark not even light can escape. No sound, no time, no way back. This isn't science fiction. This is a black hole. And inside it lies something so terrifying, even the laws of physics break. So what exactly lies inside of these cosmic freaks? A whole new universe? A matrix of parallel universes, wormholes, white holes, or just a cosmic dead end? You're about to enter a place where reality ends and the unknown begins. So what exactly are black holes? Black holes form when massive stars, at least 20 to 30 times the mass of our Sun, reach the end of their life. As they exhaust their nuclear fuel, the outward pressure from fusion ceases, and gravity causes the core to collapse. If the remaining mass exceeds a certain limit, the Tolman-Oppenheimer-Volkoff limit, the collapse continues until a singularity forms, a point of infinite density. This is surrounded by the event horizon, beyond which nothing can escape, marking the birth of a stellar mass black hole. And it is this infinite density that creates gravity so immense that nothing in this cosmos can escape a black hole if it went past the event horizon. So let's imagine a hypothetical situation where we take a ride on an advanced spaceship towards a stellar black hole. So what will we find inside? Can we even enter or go near it? Stellar black holes are the smaller ones, ranging from 3 to 100 times the mass of our Sun. So the spaceship first has to go past the event horizon. Event horizon is the invisible boundary around a black hole. It's not a surface or a wall. It's a point of no return. Once you cross it, nothing can escape. Not light, not information, not even time as we understand it. Once crossed, the escape velocity required to leave the black hole's gravitational pull exceeds the speed of light. Since nothing can travel faster than light, escape is impossible. All paths, regardless of the ship's direction or propulsion, lead inward towards the singularity. So when anything approaches or crosses the event horizon, especially in the case of stellar black holes, it is spaghettified due to the ununiformity of the gravitational forces of the black hole. A person sitting in a spaceship would feel more gravitational pull at his feet rather than his head. Hence, the entire spaceship, alongside everybody inside it, will be stretched and shredded to atoms before being sucked in. So, again, for the sake of imagination, the small black holes are not possible for our cosmic adventure. So we'll have to choose a supermassive black hole. Because for supermassive black holes, the tidal forces, or the stretching effect of gravity, at the event horizon are significantly weaker than for stellar black holes. As the event horizon of a supermassive black hole is much larger, owing to the fact that supermassive black holes are the largest type of black holes, with a mass ranging from hundreds of thousands to billions of times the mass of our Sun. So, when the spaceship will try to go past the event horizon of a supermassive black hole, the gravitational gradient across the spaceship's length will be less extreme at that initial boundary. This means a spaceship and its occupants might theoretically cross the event horizon of a supermassive black hole without immediate spaghettification. Supermassive black holes are generally found at the heart of most galaxies, like Sagittarius A star, the supermassive black hole at the center of our galaxy. So let's head our hypothetical vessel to Sagittarius A star. the closest supermassive black hole to us, located in the Milky Way. It's not just a gravitational monster. It's a gateway to physics pushed to the edge. As said before, supermassive black holes have gentler tidal forces at the event horizon compared to stellar black holes. So let's assume our ship will cross the event horizon without immediate destruction. But what about survival beyond that? Still unknown. There is no explosion, no sudden shift. The ship simply passes the point of no return, the event horizon. From this point on, escape is impossible. As the ship nears the black hole, light itself begins to twist. Stars warp into halos. The universe ahead becomes increasingly distorted, causing time dilation. Minutes on board equal years outside. From Earth, the ship appears to freeze just above the event horizon. The deeper the descent, the more space itself is warped. Navigation breaks down. The crew can no longer orient. Forward means down, and down means toward the singularity. No signals escape. Ship is cut off from the universe. Tidal forces increase slowly in supermassive black holes. Gravity bends light into chaotic shifting fragments. At the heart of every black hole lies something terrifying. A place where space folds, time dies, and physics breaks. The singularity. But here's the question. If you fall into a supermassive black hole, can you survive the singularity? According to Einstein, a singularity is a point of infinite density, where gravity becomes so intense that all matter is crushed into a dimensionless point. Inside, space and time cease to exist. The math breaks. Our universe stops making sense. If you reached it, you'd be destroyed completely. No atoms, no particles, not even information would survive. So when our ship will start moving closer towards the singularity, it will start disintegrating into pieces due to the enormous disruptive force exerted by the singularity. And once the ship is too close for comfort, the unimaginably enormous gravity of the singularity will shred apart the ship, stripping off its last atom before consuming it into itself. Now that's a horrifying end to our cosmic adventure. But wait, is that it? The problem is that Einstein's theory only tells half the story. It ignores quantum mechanics, the rules that govern the smallest parts of reality. Many scientists now believe the singularity isn't real. It's just a glitch in the math, a place where our theories collapse. Other more exotic ideas suggest the singularity is a gateway, that a black hole could be a wormhole connecting distant points in space, or even to another universe. Some theories imagine the black hole bounces, creating a big bang in a baby universe on the other side. In that case, maybe you don't die. Maybe you're reborn somewhere else entirely. Some believe matter inside a black hole might not vanish, but compress to a finite, tiny state, a quantum remnant we don't yet understand. The truth is, we don't know what really happens inside a singularity. No one's ever been there. No signal has ever escaped. No theory fully works. Surviving it, at least with our current understanding, seems impossible. But the universe has a strange habit of proving us wrong. So, can you survive the singularity? Today, physics says no. But tomorrow, it might say something else entirely. In the end, the black hole isn't just a place, it's the limit of human knowledge.